Hi, welcome to QuBites, your bite-sized pieces of quantum computing. My name is Renee from Valorem Reply, and today we're going to talk about the transatlantic perspective on quantum computing, which sounds quite like something, right? Well, it's with our special expert today. It's Andre M. König. Hi, Andre, and welcome to the show. How are you today?
I am overlooking the Atlantic right outside my window. We have Hurricane Fred coming in a few hours. So a great time to be talking about transatlantic relationships.
Ah, love it, love it. Well, stay safe, please, and if there's any interruption, we all know why that is. Well, first of all, can you tell us a bit about yourself and your background as it relates to quantum computing, security, and related topics?
Originally from Germany, just like you, I've lived in the US for the last 20 years. I'm a consultant, entrepreneur, investor by trade over the last 25 years. And I now run three companies in quantum interference advisors, the Gartner of quantum computing, where we collect data and analysis on the ecosystem. One Quantum, a global quantum tech community with over 20 regional chapters, and a tiny little investment fund.
Nice, nice. Well, and that's actually one of my first topics I wanted to ask you because you do so many things. And I also saw that you have your own video series on YouTube called A Weekly Quantum World, and with a couple of other professionals as well as community activities you're doing in the quantum computing space, right? And like you said, you're originally from Germany, and in German we say, "Du bist aber ganz schön umtriebig," which would probably translate to something like, "You're quite a go-getter," right? So tell us a little bit about your YouTube show and maybe some of the other highlights from your other activities you're doing.
Weekly Quantum World Detangled. So we try to detangle news and stories and influencer really globally from the quantum tech world, not just quantum computing, but sensing, communications, quantum key distribution. And we talk to everybody, to founders, to big vendors, to investors. We've had government officials on our show. And we really just try to put a face on names. Quantum, even globally, is still a small, albeit rapidly growing community, but there are names that all of us know, right? So we just try to get those names on camera, get to know them personally a little bit, their views and perspectives on quantum, and where they think the quantum universe is heading. I can't claim that I have a favorite so far. It's just really fascinating. We've spoken with world famous senior scientists from the US, from Japan, from Germany. Hello, Frank Wilhelm. We've spoken to big investors. We had a 15-year-old high school girl on our show who started a high school quantum computing club. One of my
Wow.
favorite interview stories so far was maybe Claire's from Berkeley, who looks at the intersection of biology and quantum computing. And maybe we are qubits and don't even know it. So that was a fascinating conversation.
Right, right. Yeah, I always love the philosophical perspective also when we're thinking about like that we can solve certain computing challenges like machine learning, like quantum machine learning, right? Some of them are not just faster on quantum computing algorithms, but also more precise, right? Because maybe we can model the world more closely like it actually works, right? Who knows? But yeah, I love these fascinating perspectives as well. And since you're one of the leaders in the quantum computing business world, right? Let's talk about some of the use cases, the timeline, and the general health of the ecosystem. Um, where are you seeing the biggest impact today, and what is going to happen in the next couple of years in terms of use cases in the ecosystem, and from your perspective?
I'll need that printed and framed for you for my wall. One of the leaders in quantum. I'll expect that in the mail from you, Renee. You know, Feynman said if you want to understand nature, you can't look at it so damn classically. And that is what quantum is trying to do, right? Not just understand nature and weather systems like Hurricane Fred that is approaching now, which is just really, really difficult to calculate for a supercomputer. Not necessarily because we don't have the power or the speed, but because it's mathematically tough to understand for a classical computer. And that's the stage where quantum computing is at, right? We're really at an experimental tiptoeing stage, trying to understand what they can do and what they cannot do while building our hardware capabilities, our software capabilities, and a wider ecosystem of users, consultants, media, investors, and so forth. And it's a race. And like a fun race, sometimes one person is leading, then the other company is leading. All of a sudden, you have a crazy startup that nobody took serious coming out of left field with a few hundred million in investments. So we're still at a very experimental stage. I think it's too early to talk about use cases. It is well published what theoretically we can do: financial models, personalized medicine, weather forecasting, new materials. You mentioned machine learning, which is a huge application, logistics, solving the traveling salesman problem. What this really means at the business level, which will also depend on how do we integrate it with legacy IT, existing processes, and does the bottom line impact make sense? We're still a couple of years away from that. I think other applications like quantum communications, where we're building a quantum internet, quantum sensors that have huge applications in GPS and mining, in medicine, and QKD that we're really seeing being rolled out to safeguard encryption, more tangible and more near term in the immediate, call it 12 to 18 months. But quantum computing, anything could happen. It's an exciting field, and maybe a Tony Stark will emerge and save the world and become the first trillionaire.
Yeah, maybe. Yeah, that's a good point. What we definitely, for example, what we do is we work a lot of quantum inspired computing and quantum inspired optimization. And you mentioned traveling salesman problems. So, for example, for one of our clients, we implemented a QuBites solution using basically an optimization solver using quantum inspired computing that runs just on a GPU array, right? Not on a real quantum computer, but it's even faster. It saves them 20% time compared to classic optimization algorithm, right? And if you take this in the future and put it on a powerful enough quantum computer, it will just fly. It's even faster, right? And that's the big thing is like where folks need to think about now. That at least that's my perspective. You got to be ahead of it because it's going to happen and it will maybe come faster than expected, right?
And that's a
Um,
great example of the power of quantum. So far, the big toe of one of our feet has taken the first step on this quantum journey. We're really just at the beginning, and we're already seeing this tremendous potential.
yeah. But let's come back to the title of this episode, the Transatlantic Perspective in Quantum Computing. And you just said you can actually look out on the Atlantic, which is pretty amazing. So you're living in the US for many years now, and but you still keep a good eye on the European quantum computing market, right? And so I think you have a good overview of both continents, if you will, right? And in your opinion, what is the main difference between Europe and the US when it comes to quantum computing business and the funding, especially?
I actually was speaking to somebody in Israel this morning just before you and I got on, and he said, I just want to figure out how I can find a future at IBM, at Google, Microsoft, Amazon, working in quantum, because in Israel we don't have it. And I said, "What? Why don't you believe in Israel?" He then turned to Europe and Germany. Well, in Germany, at least you have higher volume in terms of GDP, population, and so forth, but you also have the manufacturing, which we in Israel don't have. And I think that was a really interesting point. So Europe and Germany compared to the US is really different. In the US, you have these big champions, you have very aggressive commercialization. What IBM Big Blue has done for the quantum computing market, basically creating it out of nowhere, spinning up, I think, 21 quantum machines that are now available in the cloud, building huge ecosystems is absolutely tremendous. In terms of bottom line impact and helping a bank, an environmental organization that wants to tackle climate change, or a car company come up with a new product, a new technology, a real innovative breakthrough, might not be the best approach. And I think Europe, especially, and Germany is playing a leading role in terms of quantum technologies there, with the second highest government spending in the world after China, a tremendous hubs that are emerging in Munich, in the Northwest, and other areas of Germany. We have the research, we have the skills, we have, as my Israeli friend this morning said, the manufacturing and engineering capabilities, experience.
Mhm.
We just need to find the use case, and we need to get private capital excited. So I think it's very different approaches, very different models. And I love Europe, I love Germany, but in 20 years in the US, I've never been this excited about the potential for Europe and for Germany in leading a technology and using it for good, hopefully.
Yeah, yeah. Yeah, fully agreed. And like you said, there's this diverse set of skills because like a lot of folks think, hey, when they hear about quantum computing, you need to have a PhD in quantum physics, which could help for certain things, right? But it's such a diverse technology that you need also diverse roles, right? You need even designers, you need, I don't know, project management, you need business development and all of that. And like you said, the real use cases as well is, for example, with Germany being strong in manufacturing, automotive, and so on, there's so many potential use cases where it can be applied, right? And so I fully agree with what you're saying.
And that is
Well,
an incredibly important point. We finished a strategic project for the Department of Defense 6 months ago, where we did a gap analysis between the current and future state of quantum. And the workforce was the single biggest issue here. Over 80% are PhDs, which is crazy and amazing. We need these PhDs. We can't do without them. But to your point, we need everything else as well: developers, experts, consultants, designers, marketers, vendors, and so forth. And that is a tremendous opportunity for everybody willing to grasp it.
yeah, yeah, fully agree. Well, we could talk for many more hours, but we're already at the end of the show. So thank you so much, Andre, for joining us today and sharing your insights. That was very much appreciated.
Great to be with you. Have a great weekend.
Yeah. And thanks everyone for joining us for another episode of QBites, your bite-sized piece of quantum computing. Watch our blog, follow our social media channels to hear all about the next episodes of the fresh season 3. Take care, everyone, and see you soon. Bye bye.